Welcome to a lesson with Dr. Powell. Let's use some properties of definite integrals in order to answer a question. Namely, we're given some information here between two different functions. And we'd like to be able to identify what this is. What is the definite integral, meaning the net area between the curve f of x and the x-axis between 4 and 5? Okay, first of all, realize that a definite integral has a lot to do with antiderivatives, so that we can naturally just pass over across addition. So this statement right here is nothing more than just saying splitting it up like this. So we know this plus this is equal to 3. That's good for starters. Next, notice that this, in a similar fashion, see these negatives, we can factor out a negative, and just like with an antiderivative, we can factor the negative out. We can, for a derivative or antiderivative, we can do the same thing here, and then multiply it to the other side even. So really, what this tells us is that this is equal to -1. But then again, we can rewrite this as 1 for f of x dx plus 1 for g of x dx is equal to -1. Okay. Now, let's take a look at this one, and let's rewrite it in another way. Let's see this 5 to 4. We can replace this and change it to 4 to 5 if we make it negative, and we can even pull the 2 out, just like we would with the derivative or antiderivative. So say -2 multiplied by 4 to 5. We made it negative because we're reversing the order of integration, or the order of the integral here. So 4, 5, and we have g of x dx, and that's going to be equal to 4. So this tells us we can divide by this -2 on both sides and end up just getting -2 over there. Okay, so let's see what we have. The integral from 4 to 5 of g of x plus the integral from 1 to 4, I mean, that's the total net change of the antiderivative function of g, or the area function even, one or the other, it's the same, from 1 to 5. So if we were to take this right here, this equation, and add it on to this equation, let's see what happens. This is going to add on this side to just give us the integral 1 to 5 g of x dx, is a total change from 1 all the way to 5, because we did from 1 to 4, then 4 to 5. And then over here we still have, let's see, we already used this piece of information, so I'll just erase it. Right. Okay, on this, but then we still have this on this side, 1 to 4 f of x dx plus, and then this -1 and this -2 have added together to give us -3. Okay, so this is good. We have this kind of equation. We also have this equation right here. Notice that in this equation, this guy and this guy are the exact same. So if we subtracted the equations from each other, in fact, if we take this equation and subtract off this equation and see what happens, we get 3 minus a -3, so give us 6 on the right side. Over here, this minus this would cancel out, and we're left with this integral minus this one. So this is the change from 1 to 5 minus the change from 1 to 4. Wouldn't that just give us the change from 4 to 5? and it does. And we were successful at determining that the integral, the area between the curve f of x and the x-axis on the interval from 4 to 5 is exactly 6. And we did this using basic ideas of that the antiderivative is simply like, or that the definite integral is just change of antiderivative, or even change of area, just thinking consecutively on intervals and maybe reversing order to be negative, and thinking about an antiderivative type situation where this integral symbol can split across addition, as well as things factoring out, like here. Thanks for watching.